Let's do this problem from your lab assignment, section 6.2. This is problem number 2. We want to find the volume of the solid obtained by rotating the region bounded by the curves in the x-axis. So we're going to take this curve y is equal to 7 minus 7x squared, and y is equal to 0. Let's see, y is equal to 0, I think, is the x-axis. So this looks like it's going to be an upside down parabola, and if we set x equal to 0, y is going to equal to 7, so that's going to be your y-intercept. And the parabola is going to be centered around 7, x is equal to 0 and y is equal to 7. Okay, and that's going to be rotated about the x-axis. So let's first try to figure out what this is going to look like. With a vertical strip of delta x creates a disk. The radius of the disk is going to be r is equal to, well, it's going to be the length from, it's going to be a y value length. And so it looks like y is already equal to this thing. So I think that's going to be your radius as well. So it's going to be 7 minus 7x squared. And then they want us to sketch the region. So this is just the two-dimensional region. And the two-dimensional region is going to be the parabola and the x-axis. So I know it's not this one, it's not this one. The parabola goes and gets intersected at 1, -1. It's not being cut in half because we don't have the y-axis as another boundary. That's x is equal to 0. So I think it's going to be this parabola. And then now we spin that around. That's when we're going to spin it around. If we spin it around, let's see, our cuts are going to look like they're going to be along the x-axis. In fact, they did mention that we have a delta x. So if you have a delta x, you have to imagine that your disks are being spun around the x-axis. So it could be this or it could be this. Since we are talking about that whole thing being spun around, I think it's going to be the second graph choice. All right. So we have the two-dimensional region. We got an idea of the three-dimensional graph, how it's going to look like. The cross-sectional cuts are going to be this. The area is going to be pi r squared, so it's going to be pi. Well, they just want the generic formula for the cross-sectional cut of a disk. So that's going to be pi r squared. We've established that the radius is equal to this. So cross-sectional cuts are going to be pi times 7 minus 7x squared. That's your r, close the parentheses, and then we have to square that as well. So now we have the idea for integrand. We want to look at the intersection of the graph, whether we're looking at the three-dimensional case or the two-dimensional case probably would be easier. This is the one that we chose. But really what you want to do is you want to set these two functions equal to each other. So when y is equal to 0, you have 7 equals 7x squared. So 7 minus 7x squared equals 0. We can divide out by 7, and it's going to be x squared is equal to 1. And you solve for that, you get it plus and minus 1. So minus 1 is a lesser number, positive 1 is the larger number, and so those are going to be your limits. So those are your x value limits. You're going to integrate from minus 1 to positive 1 of your pi times 7 minus 7x squared quantity squared. This is symmetric, so we can just, whatever we get for the first one is going to be the same as the second one. Well, let's get to that in a minute. We have pi as a constant that we can take outside, and then it looks like they FOIL this out because that's just going to make things easier. So 7 squared is 49. We have 7x squared. That's going to be 7 times 7 is 49. You double that, you get 98. And then you're going to get 49, 49x squared squared. So that's going to be x to the fourth. Now you integrate. We're going to get 49x. And then we have a minus, and then we're going to get 98x cubed over 3. And then we have 49. That's a 49x to the fifth over 5 because we're taking the integral. So now they want to compute this by putting 1 and -1 in. This looks like it's going to be a lot of algebra work, or not even algebra, it's more like arithmetic work when we put 1 in and -1. So I'm going to call on some help here with Wolfram Alpha. So I'm going to notice that this is going to be a pi, and then I'm going to get a 49 times 1, so that's 49, and then a minus 98 over 3, and then a plus 49 over 5. Now that's what happens when I put 1 in. When I put -1, I'm going to get negative of all these, but I'm going to subtract it, so I'm actually going to double that. So it's going to be times 2. This whole thing times 2. I suppose I can just plug in our answer, but let me just have Wolfram work this out for me. I'll leave the pi there. I have well, I can still put pi times I have 49 minus 98 over 3 plus 49 over 5, and then multiply the whole thing times 2. That's 164.2 something, but let's see if this makes it look a little bit nicer. 784 pi over 15. I think this would be correct because when they're asking for symbols, they usually run it through a parser and then find the equivalent value, actually using Mathematica as well. So they check this off as being correct, and mathematically it's 784 pi over 15, which is what we got anyways. So just be careful when you're doing this algebra, if you are doing the arithmetic, to get the answer. Okay, that's it for that one. Hope that helps.